A sub n, it's asking you for the term in the sequence. When you see S sub n, it's asking you to add up those terms together. So it says, given this sequence, 1, 4, 7, 10, 13, right? This is arithmetic. You're going up by 3 every time. If they asked you S sub 6, they want you to add together the first 6 terms. But if they just asked you what A sub 6 was, you would just say the answer is 16, right? So there's a difference between saying S sub 6 and A sub 6. So on the next quiz, you're going to have 2 different notations to look out for. One is just asking you for the single term. One is asking you to add up the terms that lead up to it. And it says to add up all the terms in a finite, it has to be finite, arithmetic sequence, the following strategy can be used. And it's to pair up the first with the last. So if you wanted to add up 2, 5, 8, 11, and you wanted to go all the way out to the first 10 terms, here's my 2, 5, 8, 11, 14, and then I wrapped it 17, 20, 23, 26, 29. And if you notice, the first and the last add up to the same thing that each of these pairs of numbers add up to, right? They all add up to 31, and there would be 5 sets of pairs. It's a very visual formula. So to me, if you don't want to remember this as a formula, this formula should actually say A sub 1 right there. I keep forgetting to, that's a typo. So for a finite arithmetic series, S sub n, whatever n is, if you take 10 terms, you do 10 divided by 2 to get the number of pairs. If S is the first 100 terms, you would take 100 divided by 2 to get the first 50 pairs. So this is your number of pairs. And then this is your first and your last term. And that's all this formula says. Do what Gauss did. Add together the first term and the last term to get 101 and multiply by the number of pairs, 50. So you're not going to have to write out this formula, but it's one of the formulas you'll need memorized. So you have to have memorized how to write an arithmetic sequence, a geometric sequence, and how to add up these pairs without a calculator. So I don't need a calculator to do 101 times 50, right? Because you would do 100 times 50, and that would give you 5, 0, 0, and then 1 times 50 is 50. So it'd be 50, 50. So you could do that without a calculator. So part of your sequence or series test will require you to use this formula. So number 1 is the same example I already told you. How do I find the sum of the first 100 positive integers 1 to 100? It is, right, 1 plus 100 is 101 times 50 pair gives me 50, 50. See if you can use that same formula to find the sum in example 2. So what's the sum of the first 20 odd integers? So the nice thing is they gave you the starting term and they gave you the ending term. So it's really easy to see the sum. What would be the sum? 1 plus 39 is 40. And well, what do I have to multiply by? I have 20 integers, but I'd only have 10 pair. So 400 would be the sum. To me, this is kind of the easy version of what they could give you because they've given you all the information. They gave you the first, they gave you the last, and they told you how many of them there were. Number 3 is a little bit more challenging because they gave you the first, they gave you the last, but they didn't tell you how many positive integers there are from 205 up to 300. And this is a little bit tricky. How many integers do you think there are from 205 to 300? Well, 205, 206, 207, 208. How many do you think there are? That's what my brain tells me. So I want to show you why your brain is tricking you just a little bit. Nope. Let's just count from 12 to 20. So how many do you think there are from 12 to 20? If you use the same logic, you might think 8, right? Let's list them. 12, 13, 14, 15, 16, 17, 18, 19, 20. Let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9. So when you subtract these two terms, one of the two ends basically gets left out. So you basically are subtracting the beginning and the end, but you have to add one additional term to represent like the beginning or the end that got subtracted. So I'm trying to like loosely prove to you that if you do subtraction, right, we thought it was 8, there's actually 9 terms. So from 205 up to 300, how many terms really are there? 96. So that's how many terms there are. So there's 96 terms. So now you have to calculate what the total sum would be. So you know your first, you know your last, and now you know the number of pairs. So what would be the sum? This would be a good calculator question. So we're taking 505 and isn't 96 divided by 2, 48? Okay, so 48 times 505, right? 505 times 48 is 24240. Another thing to point out, could you have an odd number of terms? So let's think about what might happen in a future case here. What if I wanted to add up 15, 16, and 17? Let's just see if it works for 15, 16, and 17. How many terms do I have? 3. So how many pairs would I have? I would have 1.5 pairs. All right, and then what is 15 plus 17? Is that 32, right? 15 plus 17 is 32. So 1.5 times 32 is 48. What is 15 plus 16 plus 17? Also 48. So even if you only have an odd number, you'll have like 1.5 pairs and it still will get you the right sum. So this works even for an odd number of terms that can't get all paired up, which I think is kind of cool. All right, so that's what made number 3 a little bit tricky, is kind of knowing this. If you subtract them, don't forget to add one term back on. Number 4 is a little bit tricky. They use a different term. They call it the 150th partial sum. That just means add up the first 150 terms, but they don't give you the last term of this sequence, right? So you have to write the formula to be able to generate term number 150 so you can use the formula. So see if you can, this is like the quiz yesterday, right? Generate a formula for this, plug in 150, that'll be your final term, then use the formula to do the sum. So you're just going to keep practicing arithmetic sequences as we do series, right? Find the difference, write the formula. I'll check which if we had done the spreadsheet exploration, the Google, what is it, Google Sheets, they use Sigma. Have you seen that before? And you just have to know kind of what the parts are in this notation. This little I really is any variable. Sometimes they use I. Your calculator, we're going to use X. Like, what should I start at? So this says, let's start at term 1. And let's say we want to do 100 integers, we would end at term number 100. If we only want to do 6, we would end at 6. And then here's where you type in your actual sequence. So it's like typing in a function. So what this notation says, start here, plug in 1, see what you get. Then add when you plug in 2 and see what you get. Plug in 3, see what you get. So this symbol says keep plugging in your input and adding together your outputs until you get to this stopping term. So like 1 to 100 or 1 to 6. If you don't want to start at 1, let's say you want to add together months April through December. You might want to start at term 4 and go to term 12. So you could start here at term 4 and go to term 12 and add together those months. All right, so if we wanted to do the same thing with just that 100 positive integers, the way we would write it, and we already know the answer, but you would say X goes from 1 to 100, And then we have to write out the formula. So 1 plus 1 times n minus 1 would be our arithmetic formula for that. I want you to practice typing that into the calculator because the notation on the calculator is tricky. Guess where it is? It's under the math key, and it's the summation button. Do you see that on choice 0? Who doesn't have a calculator? Everyone have one? Okay. So see, it's under summation. You're going to use this button a lot in this unit. So we're going to practice this again on Monday for people who forget. So you're going to type the variable key. I always just use this variable key x right here. So x goes from 1. Use your arrow key, 1 to 100. Then use your arrow key, 1 plus 1 times x minus 1. You need to write your own parentheses here. The summation has its own parentheses here. You cannot go outside of the black parentheses or it won't work. So make sure you use your own parentheses or else it won't know that it's inside the summation. So that gives you that the answer is 50-50. Did it work? All right, see if you can do number 6 the same way. How would I express, we already know the answer, this is from the previous page. What's the sum of the first 20 odd integers using the summation notation on your calculator? It's a cool new button. I love learning new things on the calculator. You guys can teach me a lot on stats stuff on the calculator, I think. Okay. We're on 508, learning about some arithmetic. That was my starting value, and then my common difference was 1, right? So you could have also written it as just n, because n is 1, n is 2, n is 3. So shortcut, this could have just been n. On this one, though, I don't think you should do the shortcut. This one, x goes from 1 up to, there are 20 odd integers, so I'm doing 20 terms. 1 plus 2 times n minus 1. But n is really x on your calculator, so, I mean, it's just the variable key. So it's under the math key. X goes from 1 to 20, 1 plus 2 times n minus 1. So make sure you can get that typed in properly. The extra parentheses from the calculator should be kind of outside everything that you type. If you go outside of those parentheses, your calculator won't do it right. Did you get 400? Does anyone need to look at the calculator and see what they typed in wrong? This is like super important foundation skill. We're going to use the rest of the unit. You have to know this sigma notation. So this is their parenthesis right now. Here you want outside of it. So you're going to just keep typing parentheses using your parentheses. X minus 1. And then close parentheses. So see how you stay inside, yours is on the outside. So then it'll work. Did you get it to work? No, I don't think so. All right, take a look at the next example. We're going to do example 7 together. Well, you wrote an extra 2 here. Oh, you turned on that side? Oh, isn't it n minus 1 now? Oh, that's all right, take a look at 7 and 8, and then we're going to come back. You can use this instead of doing kind of the spreadsheet work. We're going to do the work using this. All right, so this says in a golf tournament, the 16 golfers with low scores win cash prizes. First place gets 1,000, second place 950, third place 900. It says first, let's use the formula for the arithmetic series. How much prize money do we need? Then let's do the sigma notation and just verify it on the calculator. So to use the formula, we need to know the number of pairs, and then we need the first term of the sequence and the last term of the sequence. We know the first term, right? The first term is 1,000. Do we know anything else? Do we either know the number of pairs or the last term of the pattern? There's 8 pairs. I need to figure out the last term of the pattern. So what's the pattern? Each time it goes down by 50. So you're going to have to find term 16, right? So we're going to do 1,000. We're going down by 50 15 times, right? Because n minus 1, 16 minus 1 would be 15. So what's our last amount of prize money? 100 minus 50 times 15. Oh, 1,000 minus 50 times 15. Yeah, 250. So we should be able to add together. So this is 1250 would be the sum of the first plus the last times 8. 1250 times 8. So how much prize money do they need to take out of the bank? They're going to pay all the prize money in cash. They need 10 grand. Did you get that? 8 times 1250 would be 10 grand. So now I want you to try the same problem. How would you set up your sigma notation so that it would also come out to that same 10,000? So, and we're going to go from 1 to 16 for our prizes. And our formula is going to be 1,000 minus 50 times x minus 1. So you're going to go on your calculator to your sigma notation from 1 to 16 and just make sure, we're just practicing typing it in a couple times. You should get 10,000. And then make sure that you don't interrupt this parenthesis that goes with the sigma notation. Your parenthesis is this little guy right here. See if you can do number 8. You're finding the total sales during the first 10 years in this business. They sell 10,000 worth of skincare products the first year. They want to increase sales by 7,500 each year for the next 9 years. What's the first 10 years in business? Like, do they reach $1 million in sales? Do they meet 100,000 in sales? Businesses have those goals, right? In sales, didn't even reach 500,000 in sales. Slackers. They only reached 437,000 in sales in a skincare business. That would be pretty good. I'd take it. All right. The wording just says what terms should be added. There's nothing to add. It's just wanting you to read that the notation is 1 through 5, right? You're trying to add terms 1 through 5. That's all it's asking you on those questions. Then on number 4, 5, and 6, they want you to identify if it's arithmetic or geometric. So you could generate terms or you could just look at the type of function and what terms. So again, they want you to just say this is whatever, arithmetic or geometric, and you would add terms 1 to 8. Then finally on 7 and 8, you're adding them up. Don't just add them on the calculator, 4 plus 11 plus 18 plus 25. Use either sigma notation or the formula. Identify if they're arithmetic or geometric. The only one that was geometric had the exponent, right? This both would be a starting term of, you plug in 1, so it's probably not going to be -7 because it doesn't say n minus 1, but this is your common difference of 9, and then usually it would say n minus 1 times, but this one is written more in the arithmetic format. This is just a linear function, but we know that's arithmetic. What was the last one? 136 times 11 was it 1496? See, I have to add together, or it was easy to add together the 23 plus the 113. Then I had to count how many terms I had. So, oh, I did it wrong. I didn't divide it by 2. Okay, see, there we go. So I have to do 136 times 5.5. So 748. Good thing you checked my answer for me. So number of pairs divided by, or number of terms divided by 2 gives you your number of pairs. And Ryan, we pointed out that you could have an odd number. So even though there's an odd number of pairs, right, when you pair them up, there's going to be kind of like an odd man out. That doesn't matter. The formula takes into account there could be a middle term, and so that it takes it into account. Actually, won't this middle term, will it be half though? The sum was 136. 136 divided by 2 is 68. So the middle term in an odd set has to be half of that sum, which is why it works.